All right, so welcome. This is practice page 13 in your notes book, and we're going to talk about valence electrons. So your valence electrons for Regents chemistry are the last number in the electron configuration, and I'm just going to abbreviate that on your periodic table. So I'm just going to switch over my screen a bit, and let's go to your reference tables. And so here we have the last number, and so carbon has 4 valence electrons. And the number of valence electrons is going to determine how many bonds something makes, right? So carbon has 4 bonds. It needs 4 more electrons to attain a noble gas electron configuration. So it needs to make 4 bonds. So I like to think of the periodic table like a little bit of a game board. So carbon, I have to go 1, 2, 3, 4 hops, so it makes 4 bonds. So oxygen has 6 valence electrons. It needs 2 more to have a stable electron configuration, the same as neon, doesn't turn into neon. So oxygen needs to make 1, 2 bonds. Nitrogen has to make 1, 2, 3 bonds. Fluorine has to make 1 bond. Chlorine, 1 bond. Bromine, 1 bond. Iodine, 1 bond, right? So this is why the same group has similar chemical properties, because they have the same number of valence electrons, right? 2 bonds, 2 bonds, 2 bonds. 3 bonds, 3 bonds. 4 bonds, 4 bonds. Okay, and so on. So let's go back to our valence electrons. And so fluorine has 7 valence electrons because it is in group number 17, so 7 valence electrons. I'm just going to grab my reference table so I have a quick peek just to double check in case I forget one, which I usually don't. So phosphorus has 5, right? Because the last number in the electron configuration, 285, right? So 285 for phosphorus, 5 valence electrons. Right, so it needs to make 3 bonds to get up to 8 valence electrons. So calcium has 2 valence electrons because it's 2, 8, 8, 2, right? Calcium is going to lose those 2 valence. So I'm just going to write a 2 here. It's going to lose those 2 valence electrons and end with a 2, 8, 8 stable electron configuration, which is going to be just like argon, right? So the elements are going to either lose or gain electrons. And so since I can just keep this up right here, lithium has 1 valence electron and zinc has 2. And again, I just told you on the periodic table that carbon has 4. So now let me just click and we'll just go this way. All right, so nitrogen has 5 valence electrons, just like phosphorus because they're in the same group. Iodine has 7, just like fluorine, they're in the same group. We did oxygen, 6. Iron has 2, I believe. Yep. And then argon has 8. So this is a full valence shell, which is called the stable octet because it is a noble gas. That's not double L. So noble gas. Barium has 2 because it's in group 2. Aluminum has 3. Potassium has 1. Helium has 2. And helium is considered a noble gas in a stable electron configuration. This is considered a full not octet because the helium, again, only has 1 energy level, and the maximum number of electrons in energy level 1 is 2 electrons maximum. So that's why helium is considered a noble gas, even though it doesn't have 8. All right, so hydrogen, 1 hop away from being helium, 1 electron away, so 1 valence electron. Makes 1 bond. Magnesium has 2 valence electrons because it's in group 2. Sulfur has valence electrons right underneath oxygen. It needs to make 2 bonds. Xenon has 8 valence electrons because it is a noble gas and it has a stable electron configuration. So stable electron configuration, sorry for my garbled mess there. And we call that, again, a full octet. And copper, see you later, copper, with 1 valence electron. All right, so we'll see you for our next video. So thank you for joining me for our walkthrough of valence electrons. So let me just quickly remind you about a Lewis dot structure. Right? If I had iodine for example, with our 7 valence electrons, the first 2 together, 1, 2, and then 1 at a time, 3, 4, 5. Now no choice but to count them up together, and then 6 and 7, leaving 1 open spot for iodine to make 1 bond. All right, so until our next video.